Have you ever had a gut feeling, a sudden insight that seemed to come from nowhere? We call this intuition. It feels almost magical, a sixth sense guiding our decisions. But what if I told you this seemingly mysterious ability is not magic at all, but a product of the intricate, powerful machinery of our brains? From a neuroscience perspective, human intuition is the result of rapid, unconscious pattern recognition. Our brains are constantly processing vast amounts of information from our experiences, building a complex web of neural connections. When we face a new situation, our brain quickly sifts through this stored knowledge, identifying familiar patterns without us even realizing it. This is why an experienced firefighter can sense danger in a burning building, or a seasoned doctor can diagnose a patient with just a glance. Their brains have learned to recognize subtle cues that a novice would miss. This brings us to a fascinating question. Can artificial intelligence, a system built on logic and data, ever truly mimic human intuition? To understand how AI approaches this, we first need to delve deeper into the biological basis of our own intuition. It all starts with neural plasticity. This is the brain's remarkable ability to reorganize itself by forming new neural connections throughout life. Every experience, every piece of information we learn, physically changes our brain. Think of it like a path in a forest. The more you walk it, the clearer and more defined it becomes. Similarly, when we repeatedly encounter certain patterns, the neural pathways associated with them strengthen. This process, known as Hebbian learning, is often summarized as neurons that fire together, wire together. This continuous rewiring is the foundation of learning and memory, both conscious and unconscious. A huge part of intuition is rooted in what psychologists call implicit learning. This is learning that happens without awareness or intent. For example, when you learn to ride a bike, you're not consciously calculating physics and balance. Your brain is implicitly learning the motor patterns required. This type of learning creates a vast, nonverbal library of knowledge that our intuition draws upon. When we make an intuitive judgment, our brain is accessing this implicit library, matching current sensory input to past patterns, and delivering a feeling or a decision in milliseconds. It's a highly efficient cognitive shortcut. Instead of methodically analyzing every detail, our brain takes a holistic look, recognizes a familiar pattern, and gives us an answer. This efficiency is crucial for survival, allowing us to make quick decisions in complex or dangerous situations. So, how does artificial intelligence attempt to replicate this? AI, particularly in the fields of machine learning and deep learning, is fundamentally built on pattern recognition. An AI system is fed enormous datasets, far more than any human could process in a lifetime. By analyzing this data, the AI learns to identify correlations and patterns. Consider a facial recognition AI. It's trained on millions of images of faces. It learns to recognize the patterns of pixels that constitute a nose, the distance between the eyes, the curve of a smile. It doesn't understand what a face is in the human sense, but it becomes incredibly proficient at identifying the statistical patterns that define one. This is analogous to how our brain learns, but on a different substrate and at a much larger scale. Artificial neural networks, the architecture behind most modern AI, are directly inspired by the human brain. They consist of layers of interconnected nodes, or neurons. When data is fed into the network, these nodes activate and pass signals to the next layer, much like biological neurons firing. The strength of the connections between these nodes, their weights, are adjusted during the training process. If the AI makes a correct prediction, the connections that led to that outcome are strengthened. If it's wrong, they're weakened. Over millions of iterations, the network fine-tunes itself to become a powerful pattern recognition engine. Let's look at a practical example, an AI designed to play chess. A grandmaster's intuition allows them to look at the board and instantly feel the right move, a result of thousands of hours of play and study. An AI like AlphaZero achieves a similar and often superior outcome. It plays millions of games against itself, learning the patterns of play that lead to victory. It doesn't have the grandmaster's subjective experience or the feeling of a good move. Instead, it performs a massive probabilistic calculation, evaluating potential outcomes based on the patterns it has learned from its training data. So while the grandmaster's intuition is a product of biological, experience-based, unconscious processing, the AI's intuition is a product of statistical analysis and computational power. Herein lies the fundamental difference. Human intuition is embodied. It's intertwined with our emotions, our memories, and our physical experiences in the world. A gut feeling is not just a thought, it's often a physiological sensation. This is because brain regions involved in decision-making are deeply connected to those that process emotions and bodily signals. Our judgments are colored by our subjective, conscious experience of the world. AI, as it exists today, has none of this. It operates in a purely digital realm, devoid of consciousness, emotion, or subjective awareness. It doesn't have a gut to have a feeling in. It processes data, identifies patterns, and calculates probabilities. It can predict human behavior with stunning accuracy, but it doesn't understand the why behind it in a human sense. For instance, an AI might analyze a person's facial expression, tone of voice, and word choice and conclude with 98% probability that they are feeling sad. It makes this determination by matching the data points to patterns it has learned from a dataset labeled with human emotions. A human, however, recognizes sadness through empathy, a process that involves mirroring the other person's emotional state in our own neural circuits. We draw on our own experiences of sadness to understand theirs. This is a level of understanding that is currently beyond the reach of AI. The AI's process is a simulation of recognition, whereas a human's is a form of shared experience. So when we ask if AI can mimic human intuition, the answer is complex. On a functional level, yes. AI can perform tasks that, in humans, would require intuition. It can spot anomalies in medical scans, predict stock market fluctuations, and identify strategic moves in complex games, often with superhuman accuracy. It does this by replicating the core mechanism of intuition, pattern recognition. By learning from vast amounts of data, AI systems build models that act as a form of computational intuition, allowing for rapid and accurate judgments without step-by-step reasoning. However, on a phenomenological level, the level of subjective experience, the answer is no. AI does not possess the biological hardware, the embodied experience, or the consciousness that gives rise to human intuition. Our intuition is a seamless blend of cognition, emotion, and bodily sensation, forged through a lifetime of interaction with the physical and social world. An AI's decision-making process, no matter how sophisticated, is an algorithmic calculation, a ghost in the machine without the machine ever being alive. In summary, human intuition is not a mystical force, but a powerful form of unconscious information processing enabled by the brain, its neural plasticity, and its ability to learn implicitly from experience. Artificial intelligence mimics the functional outcome of intuition through large-scale data analysis and sophisticated pattern recognition models. It can replicate the what, the quick, accurate judgment, but not the how or the why in a human sense. AI can imitate the results of intuition by finding patterns in data, but it does not possess the biological, conscious, and embodied experience that defines genuine human intuition. It is a powerful tool, a reflection of one of our brain's most remarkable abilities, but it is not a mind. It is a brilliant mimic, not a sentient peer. If you find this interesting, like the video and subscribe to the channel Just Fact for more science-based facts.